Well, the 1316 beta-glucans are very interesting molecules. They belong to that class of molecules which are very acutely recognized by the innate immune system, along with lipopolysaccharides, proteoglycans, flagellin. These are disease-associated molecular patterns, and the innate immune system responds to them, and it responds to them by mounting an immune response, which is designed to defend you from infection or invasion. It is very responsive to 1316 beta-glucans, and when the innate immune cells see this, they will do their best to defend you. Now, if those immune cells are in the skin, such as the Langerhans cells, which are a stationary subset of macrophages, they have the receptors that recognize the beta-glucans, the CR3 receptor amongst others, but there's other receptors too. And they then upregulate immune function in the skin. They correspond with the other cells in the lymph nodes, and they tell the immune system, we need to go into a more active mode to protect this person. But they do something else as well. Once the beta-glucans get into the skin, those immune cells assume that the skin has been broken, because under normal circumstances these molecules would not get into the skin, and so they then trigger basically a repair process. In fact, in Norway and in Germany there's a lot of research where these beta-glucans have been used to accelerate and improve recovery of surgical wounds. They enhance the healing process. The 1316 beta-glucan that you find in, for example, the yeast cell wall, these are large molecules, and they would not penetrate the skin to any significant extent. So we have to be a little bit creative. What you can do is to hydrolyze those large molecules and break them down into small fragments, and then repackage them in an emulsion or in a liposome, or using other transdermal technologies. Under those conditions, these much smaller molecules achieve penetration into the skin, and they get deep enough into the skin to engage with the Langerhans cells. Once we've done that, we can get them into the skin without breaking the skin, but the Langerhans cells still think there's been an accident, there's been some injury, we need to increase the rate of repair. So they speak to the fibroblasts. The fibroblasts then produce more collagen, more elastin, more laminectin, all of the fibers that make up the extracellular matrix. So the matrix in the area becomes more extensive, thicker, stronger, it becomes more effective, and the skin then becomes more hydrated, more elastic, more tensile strength, that becomes thicker, and really you start to reverse many of the signs of aging.